Okay, it says John believes the best way to play roulette is to place a bet on a fixed block of numbers, as the probability of winning is 6/38.
Okay. All right. So before I raise this one, let me just reiterate for the table problems, the one where they give you the tables, there's three different types. There's
Mm,
the less than, and you use the z score to just go to the table, look it up, and that value that comes back is your answer. For the more than, or to the right, to to the positive side, you take that table value and subtract it from one. And then if you have a between, you look up both z scores
and
and
you
then you
subtract the
subtract the
higher.
smaller table from the larger one. Okay.
Okay, thank you.
Okay. So who was it that had it? It was it
Leandra.
you, Leon? Okay,
Yeah,
which one was? Say it
John,
again.
it's the question about John believes the best way to play the roulette.
All right,
It's the roulette.
that's an expected value. When I'm just going to leave in the basic expected value, but I left that one in just to give you so there'd be like three of them with the same process for it.
Hmm.
Do you remember which problem it was?
The one that John believes the best way to play roulette is to place a bet on a fixed block of numbers, as the probability of winning is six over
What's the
30.
question number though? What is the question number? I want to see if it's
It's 10.
10.
Mm,
Let's see if I think I just forgot to turn off the scramble because before we had them and they were.
yeah, it's all scrambled.
But it is in the review, right?
Yeah.
And sometimes it could be a slightly different problem. They'll
Hmm.
have one. Okay. Joan believes the best way to play roulette is to place a bet on a six block of numbers as the probability of winning is 638. Is that it?
Yeah.
Okay. See if I can go to it here.
Hmm.
Yeah, they'll definitely scramble. We'll find it. All right. All right. So we've got the probability of winning here. 638. And then they give us the probability of lose. So they give us everything here. This is
Yes,
38,
30.
not 32.
Yes, 30.
All right. So if he um, wins, So on the win side, again, it's usually best to have a table, but this one's not that complicated because it's just got win and lose. Oops. So this would be the win. And then the lose. So then this is the 6 over 38. And then this is the 32 over 38. And so they win $100 or they lose 20. So now, essentially what you're doing, you're multiplying X times the probability of X. And then we're going to add them up. So that's 100 over 1 times 6. So that's 600 over 38 minus, with this, I'm going to have to use a calculator, 20. So that's 320. I think it's 640, but let's double check. And it's a negative 640. You can convert them to decimals if you wish. I just don't like rounding things off until the very end. That's usually the safest way to go, because if you round too early, it can cause problems because you can't ever get your accuracy back once you round. So if it says, and they even tell you, do not round to your final calculation. That's why they're saying that. Because if you round to the cents early, then any kind of inaccuracy is going to be kind of sent through the process, so to speak, and come out the other end. All right, so then this is 40 divided by 38. So that's negative $1 and 5 cents. So that's saying that every time the person plays by this strategy, they're losing $1.05 on the average. That's not to say that they won't win. It's not to say that you can predict what's going to happen on anyone, but over the long haul, playing it lots of times, $1.05 is what this person would lose. Okay.
Okay, thanks.
So we okay on this one?
Yeah.
All right. I'm just going to scroll by until I see one that looks interesting. If y'all see one. This one kind of all right. So we got a survey of 45 technicians found that 20 like the Java language, 15 like the Python language, and 7 like both languages. How many computer technicians like neither? All right. So again, we're using this formula. This is the OR. Okay. So now we're going to just fill in the blanks with what we got. So A would be Java. B would be Python. Minus the ones that like both. Okay. Okay, hold on a second. Now, these are the ones that I get to point out. All right. What does that 28 represent? It's 28 that like both. I'm sorry, they like Java or Python or both. Okay, that's what that is. That's the formula for the union. Okay. So what we got to use is the complement rule.
Wouldn't you just add it all up and subtract it from 45 or no?
Yeah, that's what I was going to say is now I was just trying to make sure that people understood that what we got here is the ones that like Java or Python. Okay. So to find neither, okay, so there's a total of 45, and then the 28 that like both or like one or the other. So the neither is 17. Does that make sense? So we use that OR rule, the union rule, to find out the number of people that like one or the other. And so to find neither, we subtract from the total. Because if they like it, one or the other, then the neither is what's left over. All right. Y'all all right on these things? This the counting principle.
I have one that I'm pretty stuck on.
What is it?
It is a random, it's a sample mean problem with the empirical rule.
Oh, okay. The empirical rule one.
Yeah,
I
it's
think that was
the
down here, isn't it?
given city has a sample mean of
Right.
1957. The sample standard deviation is 149. Use the empirical rule to determine the percentage.
There's only one empirical rule in here. I'll find it. I think it's toward the end.
See, mine's number 2.
Yeah, here we go.
Thank you.
A random sample of daily calorie intakes for people in a given city has a sample mean of 1937 and a standard deviation of 149. Use the empirical rule to determine the approximate percentage of daily calorie intakes between. Okay, so I want to make sure you understand this first. The empirical rule, sometimes called the 68, 95, and 99.7 rule,
Is that the 2-3 deviation?
Yeah. Just wanted to bring it up so everyone knows
Okay, so there's
exactly what
the
I'm
two,
using.
I think that's what I'm getting confused too, is there's two of them.
Yeah, the procedure is the same in each one to find the boundaries. It's just that for that other one, I think you asked about it yesterday, the Chevy-Chev rule. I'm not going to have that on the exam. I could not take it out
Okay,
of the review.
that's what I had confused.
But it works the same way.
why-
It's just a different percentage.
Okay.
Oh, I should have just started at the back and came forward. Okay, so this is the empirical rule. So if it's between one standard deviation, that's 68%. Two standard deviations is 95, and 3 is the 99.7. Now, what we got to determine is how far standard deviation wise is it from the mean to this endpoint. I'm going to do this one first, the positive one, just so I can add. All right. So watch this. So my standard deviation is 149. All right. Now, 1937 is my mean. I'm going to add one standard deviation to it. And that gives me up to 2086. I'm not there yet, so I'm going to add one more. So that brings me up to 2235. I'm still not there yet. One more. And that brings me up to the 2384. How many was that? I added it 3 times, right?
Would be 99.7.
So that's the 99.7.
Okay,
1, 2, 3.
gotcha. Thank you.
Mhm. And this is another unexpected value. You just basically multiply them across and add them up. Oh, that was to the right. All right. So, let's see. So I did that one and then. Oh, we did this one, and then I didn't put in the answer. All right, so let's look at a little probability. A magician draws a card out of a simplified deck. Well, I'm sorry, out of a standard deck. What is the probability that the card is not a 4? Well, basically, we're just going to find the probability of a 4 first. And so there's 4 4s in there out of 52. 1/13. All right. So it's not a 4. So 12 out of each suit is not a 4. 12/13. I wish I had knocked some more out of here just for the review. I took some of them out, but I never had a chance to go through it. Unless you take it again, you wouldn't notice anyway. So of the 43 applications received for a new job, 32 had experience. 24 college graduates. 20 have experience and a college graduate. Who has an experience and is a college graduate? All right. Let's see. I'm just going to put E. And what was it? Experience. So E, U, experience. So it's college graduates. That's what it is. All right. So they gave us these things. Hold on a second. What in the world is this thing asking? "32 have experience, 24 have and a college graduate."
Wouldn't it be the 20 out of 43?
Well, that's what I'm thinking. I mean, is it that simple? I was thinking it was going to ask for or. And wants it to decimal. Yeah, I mean, they're just asking us to repeat it. There's nothing really to do. .465. 0.4.
It's 4 decimal.
Yeah, 40. All right. That just seems awful strange. Why they would give you that, and then there's not anything really to do. It just regurgitate the problem. You have to read it. See, now this is kind of what I was thinking it was going to be, and it was going to be like this one. All right, because this one is asking for the so it's R or TV. All right, so and so they want the or, so we're just going to add those two up and subtract. I think that's 0.97.
Yeah.
Yeah. Oh, yeah. So the city council conducts a survey of the city's residents to determine which services are most used by the community. 35% of the residents say they use the library and the recycling center, and 60 of them say they use the library. All right. So this is that same formula for the conditional probability. So probability of B given A is equal to the probability of B and A over the probability of A. So in this case, the city council conducts a survey of the city's residents to determine which services are the most used by the community. Say they use the library. So let's just say so given they use the library, and then this is the recycling thing. So we're following that pattern. So we know the probability of the library is 35. I'm going to write it as a decimal. Write everything as a decimal. See, 35% of the residents say they use the library. Oh, and the recycling center. That's in the numerator. That's library and recycling center. So that's 0.35 up there. 60% of the residents say they use the library. There we go. So now 0.35 divided by 0.60, 0.58. Oh, they want us to do it as a decimal. I mean, as a fraction. So let me just back up and do 35 over 68. Okay, 5, 6, 7, 8. So neither one of these. So I think that's it. We can't simplify that any.
But it could be written as whole numbers like that?
Well, it's a probability.
Okay,
It's not a
so
whole number. It's a fraction.
the point, okay.
When I
It's
put
just
that,
that, okay,
when I put that in,
well,
I got 712.
What?
you got
Was-
what?
712. 7 over 12.
You know what? You might, let's see.
That's what I got, 2 7 over 12.
So
As the
68. Okay, hold on a second. Let me see. I did a quick.
You like
Oh,
when
it's 60, not 60. It's 60, not 68.
so when you
Okay.
I got 5, 8, 3
Yeah,
repetitive,
let me.
and then I just did the fraction decimal button, and it gave me 712.
Yeah, it'll do that. Yeah. So then it's 35
Yeah, that's
over 60.
75.
They're both divisible by 5. So 7/12 exactly. Thanks. I don't know why I was seeing that. See, that's what I'm saying is one of the traps you fall into is falling for your own handwriting. And like I said, I saw it as a 68. All right, y'all have anything else y'all want to look at before we break, or y'all want to?
Not
No.
currently, but
Break
I'll
early.
have
If
something.
All right,
anybody's got anything, like I said, is I'm just
I know my most is the Z-score chart, like y'all went over.
uh-huh.
That's my biggest one that I'm still a little.
All right. Well, we'll do that because Justice sent me some problems. She's
Okay,
got the
perfect.
one about the area under the curve between
Okay, that'll be
these
perfect.
scores. Okay. She's asking about that big truth table one. She's asking about the one that we looked at with the roulette.
Mhm.
Okay.
So
All
whenever
right.
we
So has anybody got anything? What's that?
Oh, I was saying whenever we go over that, that'll be my time to go over that. Then that's fine.
Okay. All right. She's also got another table one, and then she's got the standard deviation one. The one where you actually got to calculate the standard deviation within that little table. All right. So I'll see you back in a few minutes. If you got anything, stick around. I'm here for till everybody's gone.
So, Mr. Cruz, I have a question about, just so I know, I'm to find it. I think it's number 4 on my.
Which one was it?
It says about the one about the weather.
The what?
Hold on, I'm finding the for you. A local meteorology office announces to the town that there is a 11% chance it will rain tomorrow. If a resident wants to know the odds that it will rain, what are the odds?
Oh, odds one. Okay. Odds. Yeah, I can do that. I think that's towards the end. That's an odd number. There we go. A local meteorologist announces to the town that there is 11% chance it will rain tomorrow. If a resident wants to know the odds that it will rain, what are the odds it will rain? Okay. So, all right. So now we want odds in favor, odds it will. So, let me kind of write this slightly different for a second. 11 over 100. And then this is 89 over 100. Okay. It's the same thing, but I just wanted to show you. All right. So that right there is our A, and then this is our B. All right. I just wrote them as a fraction because technically it is the numerator.
Where did they
So
get the
now, all right. So then we want the first one, it's odds in favor. So it's 11 to 89. Okay. All right. You got that? Leonza, you still out there?
Yes, I'm here.
All right. Well, I'll see you in a little bit. Okay.
Okay, thank you.